Let's have a look at example 8. It's on page 435. When the brakes are applied in a certain make of car, the length L of the skid in meters is given by L equals this expression here, where S is the speed of the car, S squared, and we've got an S here, it's a quadratic, in kilometers per hour at the time when the brakes were first applied. A car involved in an accident leaves skid marks measuring 50 meters. Determine the car's speed at the time of braking. This equation here is a relationship between the length of the skid marks and the velocity of the car, the speed of the car. Okay. If we know L, we can find S. If we know S, we can find L. In this case, we know L. It's 50 meters. All right, write the equation. We put that down. We've substituted 50 for L, and then we've rearranged it to put 0 on one side. Minus 50 from this side, we've got a minus 50 from this side. Minus 50 plus 0.3 is minus 49.7. That's a quadratic equation. Using the quadratic formula, A, B, and C are decimals, so the quadratic cannot be factorized. Okay. So we've got A equals 0.168, B is minus 0.8, and C is minus 49.7. We put that in the quadratic formula. Notice they haven't got an X here, they've got an S, because in this equation we're using S. All right, S1 is equal to minus 15, S2 is equal to 19.7. Only the positive values make sense in the context of this question. You can't have a speed of minus 15 here, okay? It doesn't make sense. So we're going to use the positive value of 19.7. The car was traveling at approximately 20 kilometers per hour. And that's the way to solve that. And this green box here, the distance a car skids depends on several factors, including the speed of the car and weather conditions. Car accident investigators use skid distances to calculate traveling speeds to help discover the cause of an accident. Very interesting.